two cars on different lanes and 88.0 meters apart start from rest and ride directly toward each other. Car A's acceleration has a magnitude of 0.300 meters per second squared, while Car B has a magnitude of 0.200 meter per second squared relative to Car A starting point. Where do the cars meet? So let us first have the givens. So for us to analyze well the problem, let the given be as shown in our illustration. So let's say this is the two-lane road. So let's say this is car A going in this direction, and car B going in the opposite direction. So we are being asked, where do these two cars meet? Let us say from the two cars meet at this point. Okay, so according to the given, these two cars is 88.0 meters apart. So this is 88 meters, and car A's acceleration is 0.300 or 0.3 meter per second squared, and the acceleration of car B is equal to 0.200 or 0.2 meter per second squared. Now we are being asked relative to car A. So this is car A. So relative to car A, where do the cars meet? Therefore, we are being asked to find this distance. Let's say from car A to this point where they have met. Let's say this is distance A. Okay, so that is distance the distance traveled by car A, and of course from car B, let this also be the distance traveled by car B, which has a total of 88.0 meters. So we are required to get the distance from car relative to car A. So we are required to get this, the distance where the two cars meet. The two cars meet relative to car A. So we're only asked to get the distance relative to car A. So let us solve for this problem. Okay, solution. Now, if we will try to analyze the problem, the time it will took, so both of these cars starts from rest. So the time it will took for car A to reach this point, is also equal for time B to travel the same time. So time A, the time it will took for car A to travel going to this point is equal to time B. The time also it will took for car B to travel going in this point where they will meet. So we can assume that time A is equal to time B. But remembering our kinematic equations and based from the givens, the given is acceleration and distance. We can choose any from the four equations, from the four kinematic equations, but the most suitable equation that we can use, that we can derive a relationship so that we can get an equation for this one, is equation number 3. According to our equation number 3, x is equal to v initial t plus 1/2 acceleration time squared. But since both cars start from 0, the initial velocity is 0. So this term will just be equal to 0. What is left is x is equal to 1/2 a t squared. Let's derive time from this equation. If we will derive time from this equation by cross multiplication, we will have 2x is equal to a t squared. Divide this by a, divide also the right side of the left side of the equation by a. This will be cancelled. So what is left on the right side is t squared, so you can also put it here. T squared is equal to 2x all over a. But to get t, we just need to get the square of t. So we have t be equal to the square root of 2x all over a. So going back to this relationship for the time of car A and the time of car B, we can substitute this equation. So time A, we can have the square root of 2x a all over acceleration of car A equal to the square root of 2 times the distance traveled by car B, 2xb all over the acceleration of car B. So we can just cancel the radical sign. It will just be the same. So you'll have 2xa all over the acceleration of car A equal to 2x of B over the acceleration of B. We can also cancel 2. So what is left is x, or the distance traveled by car A, all over the acceleration of A is equal to the distance traveled by car B, x sub B, all over the acceleration of car B. But we only need to get x sub A because we are asked to find the distance relative to car A. But if we will go back to our illustration, the total distance from car A to car B is 88 meters. So if we will add their distances, x sub A plus x sub B is equal to 88 meters. Here's your x sub B. X sub A and x sub B equal to 88 meters. Therefore, if we will substitute an equation for xb relative to x sub A with respect to x sub A, x sub B is also equal to 88 meters minus x sub A. So let us go back to our solution. X sub B x sub B is also equal to 88 minus x sub A. So we can substitute this to the x of B here, so that all the variables will just be x sub A, and we can just easily solve using algebra. So let us substitute x sub B. We'll have an equation x sub A all over acceleration of car A equal now to x sub B is 88 minus x sub A. 88 minus x sub A all over the acceleration of B. Okay, so we have now the equation the x sub A over A sub A is equal to 88 minus x sub A over A sub B. So what we need to do is just to substitute the given. So according to the given accelerations, x sub A, acceleration of car A is 0.3 meters per second squared. So let us we can already omit the units, it will just be cancelled later on, and shall become 88 minus x sub A all over the acceleration of car B, which is 0.2 meters per second squared. Now by cross multiplication we will have 0.2 x sub A equals 0.3 times 88 minus x sub A. So you will notice that the only variable left in this equation is x sub A. So we can just easily solve for x sub A by just using simple algebra. So this is 0.2 x sub A, 0.3 times 88 is 26.4 minus 0.3 x sub A. Simplifying, we'll have 0.2 x sub A. Let's transfer 0.3, negative 0.3 to the left side. This will become plus 0.3 x sub a is equal to 26.4. So 0.2 plus 0.3 is 0.5 x sub a is equal to 26.4. Divide this by 0.5. 0.5 cancel. X sub a now is equal to 26.4 divided by 0.5 is equal to 52.8 meters. So relative to car A, both cars meet 52.8 meters relative to car A. If we will go back to our figure, so 52.8 meters from car A. So from car A to this point is 52.8 meters. So that is the answer for this problem.